Hi, this is another video on electron configuration. It's going to be hopefully short and sweet. I just wanted to show you some tricks to make it easier, and then also just one other way that we can show electron configuration. So while we're doing this, we're still going to be using Aufbau's principle. Remember, that's where it has to go lowest energy filling up to higher energy orbitals. Polyexclusion principle, which is that the two electrons, if they're in the same orbital, have to spin opposite, and then Hund's rule, where if the electrons go into an orbital, they're going to go singles into equally energy orbitals, and then they'll double up if needed. And then, you should still hopefully be thinking about the shapes and names of the S, P, D, and F. And here we go. So the first thing I want to talk about is the noble gas electron configuration. It's a shortcut. And you can use it as long as just carefully look at the writing that I give you, or the way that I ask the question. I'll say complete electron configuration, which is when you don't do this, or I'll say noble gas electron configuration. So the noble gases are this far right group of elements, and they're noble because they're super unreactive, and we'll get into that with bonding. It's because they have a full valence shell of electrons. So they're very special. So when you write a noble gas configuration, what we do is, if we're doing a configuration for an element over here, we would use the noble gas that precedes it, and then instead of writing all those electrons up to that point, we can just write the symbol of the noble gas. So that'll make more sense when I show you. So let's do one here. So we'll do silver. Silver's right here. So instead of doing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, it's like a song, right? Instead of that, what I'm going to do is I'm going to pick the noble gas that precedes it, which is krypton. So then when I write krypton, and I do want to do it in brackets, that means all of those electrons up to krypton, the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Then I start counting from there. So it's kind of like a bookmark, and then you start reading from there. So then I would get here where it's n equals 5, so it would be 5s2. And then remember, these drop down by 1. So it'd be 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4d9. So that is something that I think you'll find handy, especially when you're doing really big elements So this is another example where we're going to do a larger atom with using the noble gas configuration, and we're going to be going through the F block. So on your periodic table, and I'm pulling up yours right now. If you read the periodic table, it's going like atomic number goes up by 1, and it reads left to right, and then you get to 56. Then you go down here to 57 through 70, and then you go back up. So it's kind of like taking a detour. And we're going to take the detour with our noble gas configuration of lead. So we're going to do lead, and we're going to make it a lot easier by using the noble gas that precedes it. So we would write down xenon in brackets. And then from there, so this would be n equals 6. So this would be 6s2. And then instead of going over here to the 5D, we're going to go down. And remember, these guys were n minus 2. So this is really the 4F. And remember, F has 7 orbitals, which can hold up to 14 electrons. So this part of the periodic table is 14 elements wide. So I would go down and then fill that 4F next. If I were doing like, I don't know, these all have such weird names. I can't pick one that I can even say. Let's say I was doing europium, then I would have stopped at 4F, 1, 2, 3, 4, 5, 6, 7. So you sometimes would end up down here too, but we're going to go right through it. And then we come back here. And now remember, we're in the n-1, the D block. So we would be in the 5Ds, and we're going to go all the way through. So it'd be 5d10. And then we pop back out, and we're in the 6. Again, this whole part is n, and this is n-1. So then I would be 6p2. So my highest energy electrons, by the way, would be the highest level of n, which is 6. My highest energy 6 S and P electrons. I wouldn't use or talk about these F or D electrons because they're in a lower energy level if I were to ask you to do that. Let's do one more thing, is writing orbital electron notation. This is helpful sometimes, like we did part of this in our worksheet, the electron distribution worksheet, but you only did the outermost S and P electrons. This would be, and I wouldn't make you do this for a really huge element, but let's say I was going to do just the normal configuration, the standard complete, not the noble gas configuration for phosphorus. I would, it's sometimes helpful if you actually write it out first. So it'd be 1s2, 2s2, 2p6, 3s2, 3p3. But what we would do, it's kind of like making it into an Aufbau diagram, but we're not going to try to show the energy difference. So I would draw a line for my 1s, 2, and then I draw a box. Sorry, you could do a line too, that's what I was thinking. 2s2, and then my p, remember I have 3 orbitals, so I'm going to draw them all together. 3p6. I'm doing Hund's rule right now. Now I'm doubling them using poly. That would be my 2p. And then my 3s. Again, up, down, and then my 3p. This is helpful because we're going to be learning about bonding next, and now we can see that we have these 3 unpaired electrons. So if I just write it this way, it's not as visible. So I would want you to be able to recognize these and be able to write them out, and we will talk more soon.